Okay. Hey, I'm going to go ahead and get started, everyone. So I'm going to go through the introduction here real quick, get us set up for the scenario that we're going to go through today, and then I'm going to walk through it. So I do have the recording set. That was my first. Craig, did you press the record button? So welcome to the first ever, and hopefully not the last, OraPub Firefighting Friday live how-to webinars. So real quick about myself. I'm a longtime Oracle DBA, and I specialize in Oracle database performance and predictive analysis. So I'm a performance researcher, I like to say. I do a lot of experiments, and because of that, I am also a blogger. That's where I write all this stuff down. I'm also an author of a couple books, and I'm a conference speaker, which I'm really excited about next week's conference I'm going to be speaking at. And I'm also a teacher, mentor, and coach. I work with a lot of Oracle DBAs to try and help them in their careers. I love doing that. I'm also an Oracle ACE director, which is kind of nice. If you want to connect with me, which anyone can do, I'm just a regular guy who does the same thing over and over and over, so I get good at it. The best way to contact me is through email, and that's just craig@orapub.com. I will reply to your email. If I don't in a couple of days, please resend it. Sometimes I don't get the emails, but please do contact me. In terms of OraPub's been around for about 16 years now. And I like to say it's a one-stop location for specialized training in Oracle database performance. And the people that I serve are Oracle DBAs, just like probably most of you that are actually listening to this right now. So a lot of what I do is training besides consulting work. And you might have noticed I'm starting to expand that now. In addition to the in-person training there on the left, there's a couple guys. I actually still meet the guy in the middle there every time I'm in the Bay Area. Great guy. And I remember the class, actually. Anyways, besides the in-person training, I now do the online video seminars as well. And you can see there's quite a price difference right there. Those are going fantastic. I have 7 of those right now, and I'm on track to keep producing one about every month. So I love doing those things, and that's the future of OraPub, I think. And also now, of course, I have the Firefighting Friday webinars. And those are specifically targeted to be how-to, since a lot of the training is so compacted within a few days, there's not nearly as much hands-on and case studies as I like. And so this is kind of the answer to that. So for our topic today, we're going to do an Oracle time-based analysis straight from a single AWI report, resulting in a list of solutions. Real straightforward, really nailed down scope. And the top weight event is going to be DB file sequential read, as you'll see. So just in general, here are the guidelines. I have some guidelines and rules here. I'm going to try and keep this around 30 minutes. If it starts going beyond that, then I'm going to start wrapping it up. Feel free to ask me any question you want, and I will see in the chat window. In fact, I think you can actually see that, since I don't know how to do this thing on my 2 monitors yet. Be aware that everything we say and do is being recorded right now. Feel free to personally email me with any questions afterwards. Like I said, I will respond to you. And I think I can get the recording online within 3 hours. I know there's some processing and some downloading and uploading that has to occur. So if your colleagues can't make this, then what they can do is they can just watch the webinar. All the tools that I'm going to use today, they are available for free, and you can download those right from my website. By the way, I'm always looking for good scenarios to do these webinars. So if you have one and you think it might be good, or even if you're not sure, just let me know. Okay, don't email me an AWI report, and please don't email me any data. But let me know that you might have something, and I will contact you back, and we'll see where we can go from there. Okay. Let's get started. Here's the situation. Overall performance is really bad, which means it's pervasive. It's just not one part of an application, and it's affecting all aspects of the application. And it typically, predominantly, and repeatedly occurs between 10:30 and 11:30 a.m. So it's not a surprise. That's what that means. The OS administrators are saying the IO subsystem vendors are idiots. How many times have I heard that? And the application user team, they are sick and tired of this recurring slowness. They are just flat out frustrated. And the DBA team as you may have felt yourself, is stuck right in the middle of all this, and they really don't know where to begin. Sound familiar? So here's the objective. We want to get a list of solutions that make sense, right? And we want to help other people understand what is happening. So what I'm going to use for this particular webinar, I'm going to use an AWI report that's been run between this key time, 10:30 and 11:30 in the morning. And I'm going to use my firefighting diagnostic spreadsheet, I like to call it. And you can download that right off the website, okay? So first of all, time-based analysis. I'm going to say this really fast here. Hopefully you guys are kind of familiar with this. But we're going to look at the performance situation from a time perspective, and we're going to look for the big chunks of time once we've categorized the time. And then our solutions are going to go directly at those big chunks of time, trying to reduce the big chunks of time. Now, you know there's a relationship here between all the time and the work, right? When the system processes more work, you can expect more CPU consumption, and there's probably going to be some more wait time. But today, to simplify this, I'm just going to focus on the time. We're not going to get into the workload profile at all, okay? So how have I broken up or subdivided the time? Well, we have the total time, which is loosely database time, into two categories. We got CPU time, and we have the non-idle wait time. The CPU time, you can break that up into two categories. When Oracle processes are consuming CPU, and when they're queuing at the operating system to consume CPU. We're not going to mess with the queue time at the OS today. I'm not going to do that. From the consuming standpoint, there are the Oracle foreground processes and then the Oracle background processes. And the DB CPU time, that is the foreground or the server process time. So besides the CPU time, the other big category is the non-idle wait time. And to simplify things, which works fantastic when we do this, we're going to break this up only into two categories, I/O and then everything else. And if it's not something other than I/O, it's going to be other, okay? And if it is I/O, it's either going to be read or writes. So we're going to place the top 5 wait events in one of these three categories of time right here. And we're going to get that from the AWI report. We're going to get the CPU consumption from the AWI report, and that's going to kind of start us off on this quest. Okay, now I have a little template here. There we go. That I'm going to use. I'm going to kind of fill this out. This is how I actually start my engagements, whether it's a consulting engagement or just a case study. I have a little bit summary right here. I'm going to have a list of solutions, and then if you're familiar with what I call my 3-circle analysis. One of the circles is Oracle, the other is the operating system, and the other is the application. So what we're going to do an Oracle time-based analysis, looking for the big chunks of time. Then we're going to look at the operating system very quickly, and we're going to do this through the eyes of the AWI report. And then based upon the Oracle time-based analysis and the operating system situation, that will lead us directly to the type of SQL statements that we're going to be looking for. And these are just some possible categories of SQL statements, okay? And then we will find those SQL statements. They have to be there, right? Because without SQL statements, there will be no load on the operating system and there will be no Oracle time associated with that. All right, so let's get going. So, the Diagnostic Firefighting Spreadsheet. We got to download that thing. As you'll see here, it's super easy to get the spreadsheet, okay? You just type FF Diag. That might be really small, but I just type the letters FF DIAG. And there it is at the bottom. I just updated this thing yesterday. And you just click here to, I know that's really small, isn't it? There you go. Click here to download. And as you probably notice, when you download something, you're going to be brought to a little form right here. Whoops, got to spell my name correctly. I feel like people are watching over my shoulder as I type. Very uncomfortable. All right, so you guys have probably gone through this process yourself. By the way, this is, as you know, I have many different lists that you can subscribe to. I try not to overwhelm people with emails. So I'm going to download the file. Hopefully it's there. It is. It's a nice little small file. I'm going to put that on my desktop. There it is. Unzip it. I'm on a Mac here, so it's going to put that in a folder here somewhere. There it is. And in that folder, ta-da, is the spreadsheet. Okay, so I'm actually going to put the spreadsheet right in here. And I'm going to close that up. All right, so let's go ahead and open up the spreadsheet. There we go. And it was updated, yesterday, right? No, a few days ago. Today is the 10th. So you can see there's multiple tabs on the spreadsheet. Today, I'm only going to look at the Oracle time-based analysis part of the spreadsheet. So there it is. Okay. All right. So let's start with the AWI report and fill this thing out. Okay. Now you'll notice that this is all put together. The structure is just like this right here, our time-based analysis. It's just that it's in a spreadsheet, so we don't have to keep retyping everything. All right. So we're going to go to the top 5 foreground weight events. Oh yeah, I forgot there could be some background weight events. I do include those as well, since they compete for resources just like the foreground processes do. So DB file sequential read, that's the first one. Okay, it's right there, right? DB file sequential read, and how much time? We have 8,000 seconds. Okay, I did not change the number on these, in case you're wondering. Okay, that's a weird number, 8,000. So the average wait time for a sequential read is 9 seconds. Okay, this is important to understand for this this scenario here. A sequential read is a single block physical read. So the Oracle process, to summarize, the Oracle process found out that a block that it needs is not in the Oracle buffer cache. So it makes a call to the I/O subsystem. But what is unique about a sequential read is that it is not asynchronous. It is synchronous. So Oracle times how long it takes to get that one single block. So that's why the wait time for sequential read is so useful to us, because it's a great indicator of how the read performance is on the I/O subsystem. So the average, in a sense, the average response time for a single block read is 9 milliseconds, at least during this 1 hour for these Oracle reads. Okay. We're going to come back to that in a minute. Okay, the DB CPU, I'm going to go down to the source to get the CPU times later. So the next wait event is direct path read. Gosh, I already have it in there again. Direct path read. Okay, that is a multi-block asynchronous read. Okay, so, and Oracle didn't even put, it did. There's the go. I'm sorry. There's the 210 seconds, our wait time. Average wait time is 25 milliseconds. And the next one here is, NQ waits, TX, there we go, row lock. Whoops, get that. There we go. And for row lock, it was a total of 60 seconds, and the average wait time, look at that. 2, 3. The average wait time is actually about 60 seconds. So if we have total wait time of 60 seconds and the average wait time is 60 seconds, it makes sense that this only happened once. So there's one poor user that was locked out for 60 seconds. Okay, the final wait event here. I don't have another one here. You know what? Guys, I miscategorized the time. That's where the row lock goes. And again, that time is, 60 seconds. Average wait time is 60004. That's in milliseconds. Okay. So our next wait event, here we go, is DB file scattered read. All right. And that total wait time is 42 seconds, which means, if you compare 42 to 8,000, 42 is nothing, right? It's noise. It doesn't even mean anything. It's just a distraction to cause arguments amongst DBAs. All right, the scatter read are multi-block reads, and those are typically asynchronous. So, in other words, Oracle doesn't have to wait for each individual block to be returned before it can continue, or even all of the 16 blocks that it asks for. So this average wait time is really not that useful to us, unlike the sequential reads. Okay, So that is the wait time. And let me see if I have any questions here. Let's see. Oh, thank you. Not an IO wait event. Yes, Haresh. I should have looked at the chat window. Let me see if I have any other questions here. You should. Yeah. Oh, you guys are sharp. Okay. How do we download the spreadsheet again? Just go to orapub.com, and in the upper right-hand corner, and then under the library search, just type FF Diag, D-I-A-G, and you will see the spreadsheet. Okay, it's just a tool. Oh yeah, there we go. Thank you. I'm not used to this chat window stuff yet. How does this method work with rack? Yes, it does work, and I would do this on each node. Okay? And if you want to, you can do them all together in one time-based analysis. That kind of gives you an overall picture, but usually I start with doing it with each node. And you might think it takes a lot of time, but if you just have a couple nodes, this is actually very mechanical and goes very, very quick. And it'll help you understand the relationship between the nodes very, very quickly. Okay, let's look at the CPU time now. Oh, now the questions are starting to come in here. All right. Time model statistics. This is where we're going to get our CPU consumption time. DBCPU. This is the server process or the foreground process CPU consumption. Boom. Background process time. Don't have to be a rocket scientist to figure that out. Now, I want to bring this to your attention, and I haven't delved into this, but this is a very rare situation where the background process CPU time is like half of server process time. That is weird. Okay, I've never ever seen it like that. Usually the background process time is just like a small percentage of server process time. So if I was actually doing this for a job, I would want to take a look at that and see what's going on. Find out which background process is consuming a lot of time. It seems kind of strange to me. Okay, so we've got all the time in there. Oh, except the DB time. DB time right here. Okay, DB time is all the database time, which is your CPU consumption, the non-idle wait time, plus anything extra. And if you've been following my blogs lately, you notice that there can be some significant extra time. I'm not going to talk about that today, okay? But this extra time, this gap, I call it, is right here. And this time, it's kind of reversed. DB time is less than even the CPU consumption and our top wait events. Part of that is going to be because DB time does not include background process CPU consumption, okay? But that's a whole nother discussion. Okay, so we've done our time-based analysis right now. So let's take a look at the big chunks of time. Let's start at the top right here. We have CPU compared to the non-idle wait time. So obviously there's a lot more, like twice as much non-idle wait time. All right, and if we look at a chart here, this other tab, we can see this is the wait time and this is the CPU consumption. So what that tells me is that we have an opportunity here to reduce not only the wait time, but hopefully the CPU time as well. Okay, so I look for chunks of time as opportunities. Okay, now within the wait time, clearly it's all about I/O and it's all about reads and it's all about single block reads. And each one of those on average takes 9 milliseconds. Okay, so what we're going to want to do is that we're going to want to find the SQL that's related to these single block reads right here. Okay, and that's going to be what I call physical I/O reads. Okay, so that is going to be important to me. Okay, in fact, what I'm going to do here, I'm going to start filling this out. I can see we're already at 20 after the hour here, so I'm going to start moving here. So our CPU time, okay, that is 4.4 thousand seconds. The wait, that is 4.3K seconds, okay? And within that, it's all about I/O, right? I/O reads. And in fact, the I/O reads is like 4.3K. So you can see it's all about the I/O reads right there. Whoops, 4.3K. Okay. So that's why we're going to look for these physical read SQL statements right here. Okay. Now, from the operating system perspective, My single block reads are 9 milliseconds. Okay, so let's talk about that for just a few seconds right here. Okay, my rule of thumb for I/O subsystems for reads is 10 milliseconds. It's just a rule of thumb, but I know from experience when the single block read starts to surpass 10 milliseconds, it starts to significantly impact the performance of the system. So we're not quite there, but we are really close. So if you're familiar with like a response time curve, we're getting close to the elbow of the curve. Think of it like that, okay? But it's not quite a bottleneck yet, but it has the potential. So we don't want to overload the I/O subsystem any more than we have to here, or we're going to push it over the edge. Okay, so that's kind of from a real quick weight of it perspective. We haven't talked about solutions yet. We're still setting it up. Oh, well, we are going to focus on physical reads from the application perspective. From the CPU perspective, there's really not, in this situation, a lot that I can do from an Oracle perspective to come up with a solution. It's not like we have latching where I can kind of turn some knobs and all that. But one thing I think it's important is that even though, and this is important, even though the CPU time is significantly less than the wait time, that doesn't mean the CPU time here is not important. Because what if there's a CPU bottleneck? And the Oracle processes can't get any more CPU, even though they want more CPU. See what I mean? So we need to figure out what the operating system CPU utilization is. Okay, we can do that through Oracle $V, through $V views. And if you've gotten any of my classes, and especially if you've watched the online seminar, Utilization on Steroids, you know that utilization is requirements divided by the capacity. Think of a glass of water. The empty glass is the capacity. If it's half full, then it's required to have half of the glass full. Therefore, the utilization of the glass is 50%. So without getting into the details, here's how we can figure out the operating system utilization on average during this 1 hour snapshot interval. So I can get this information here that I need by going to the operating system statistics. And there's the busy time right there that I need. Okay? And there's the idle time that I need. I'll do another seminar specifically about this, or another webinar. But anyway, there's the busy time and the idle time. Because of the method I'm using, I can shortcut this a lot. Okay, I can just say 4.7, which is the busy time, right? And divided by this 4.7 plus the idle time, and I'm going to make that 8.2. Right? It's really quick to do this, and that's going to give me the average CPU utilization. I'm going to use my Mac to do the math. Now, if you can see that, but the average utilization here is 0.36. Okay, 0.36, which is 36%. So over the snapshot interval of this report, this average CPU utilization is 36%, which means we do not have a CPU bottleneck right here. There is plenty. Did I mess that up? Oh, yes, 82. Thank you. 82.6. It's even less than 36, isn't it? Yeah, I looked at my notes because I did this before, and it's much less than this. Thank you guys for paying attention here. There we go. That would have been different, isn't it? That's about 5%. So it's 0.05, 0.05, which is about 5%. So again, clearly no CPU bottleneck, tons of CPU. In fact, somebody might need to take a look at your allocation of your budget on CPUs in this particular case. So to summarize the operating system, it looks like, I'm assuming network is okay. So that's out of scope, okay? I'll do network and memory stuff at another time. So it looks like the operating system is fine. So the issue here is not the operating system. There's plenty of capacity. You know, even if we can process a little piece of Oracle work super, super fast, if we have to process a lot of those, that time is going to add up and will impact our users. So in this case, the operating system is performing really well. We're just asking it to do a lot of pieces of work, and that's going to take some time. All right, so the OS is looking pretty good. So what I want to do now is, we want to look at the CPU. We want to look at the application SQL. Since CPU is a significant chunk of time, I'm also going to look at the top CPU statements as well. Okay, and so let's go ahead and do that. Okay, let's go ahead and find those statements. Okay. Yes, let's go ahead and do that. So let's scroll down here till we get to the SQL. Here we go. As with any AWI report, it does a pretty good job at kind of grouping SQL statements by the categories that we care about. If the category you care about is not shown there, the information is probably in the AWI tables. You're just going to have to extract those out yourself. So what we care about is the physical IOs, which is going to be my physical reads right here. So I'm going to click that, and bingo, there's our top statement right there. Got it. Okay, now the way that I write this is I'm just going to put the last 3 characters of the statement. Okay, this thing is consuming about around 59% of all of the physical reads related to this instance. 59% of all physical IO reads. That's a very good find right there. And then we have another one, which is about 17%, but I'm just going to put this first one right here. Okay. So that's the statement that we need to focus on from an application perspective, specifically trying to reduce the physical reads. Okay. Now let's go to the CPU time, or the top CPU statements, which I think is up above here. Yes, top CPU. And we have really kind of 2 statements. This one's clearly the top one right here. And notice the executions is 0. This means it hasn't finished yet. Okay, so this is probably, well, we're hoping it's a batch job because the snapshot here is like 60 minutes, unless it started near the end of the hour. But this is our big one right here. So it's X5D. It's kind of weird how they both, the third character is X, isn't it? I don't know. Anyways, for all the CPU, this is 93%. That's crazy, man. That is all about CPU. The other one here I'm going to put is the next one is the DFT statement, and that's about 46%. Okay. Now, you'll notice right here that if we start to add up all this percent totals right here, we're going to go over 100%. Okay, that is because, this X5D statement could actually be within this statement right here, like the X9T, right? This could be, I can't really see here, but like, let's say this statement was like a procedure or something, some PL SQL. Well, then this statement could be like within that PL SQL. And therefore, if you add all this time together right here, you're going to start double counting. Okay, so I would double count if I added all this time together. Okay, so watch out for that kind of thing. Okay, so let's look at some solutions. These are our solutions right here. So solutions, we are going to tune SQL X9T, focusing on reducing the physical IO reads. So tune SQL X5D, focusing on reducing CPU, which is going to be logical IOs, okay, buffer gets. Okay, now ask yourself, here's our big chunk of time. Let's go back to the spreadsheet. Here's our big chunk of time right here. What is one way to reduce the physical IO time from an Oracle-centric perspective? Better caching is one of the answers. Better caching. You see, if these blocks that we had to go to disk were actually in the buffer cache, we would not have to make a physical read call, and this time would be reduced. Just that's the way it is. Okay. So one of the things I can investigate doing is increasing the buffer cache, caching popular tables that are related to these SQL statements. All right, that kind of thing. Keep pool, that kind of stuff. Okay, now this is important though. Caching only works well if the buffers are repeatedly touched. And the reason I mention this is if we go down to this physical I/O statement right here. Oh man, did I look at the wrong thing? Yeah, well anyway, this one got run 0 times, excuse me. These are our reads. That was executed 12 times. So those blocks are probably touched multiple times. But if this was our top SQL statement, where it basically is like a batch process, there's a really good chance that the blocks will not be repeatedly touched. And therefore, increasing the buffer cache will not likely help us. So, and plus we got to make sure we have enough memory also on the OS, okay? Make sure plenty of memory at OS, okay? Okay, so we have solutions now from an application perspective. We have a solution from an Oracle perspective. And from an operating system perspective, it looks good. OS looks healthy. Don't focus on that now. Don't focus on that now. Maybe later. Okay. Okay? And that's it. Whoops. That is a really quick Oracle time-based analysis that we came up with solutions that are targeted specifically at big chunks of time, the key SQL statements based upon our time-based analysis, and by looking at the operating system as well and seeing that that is actually performing pretty good. So that brings us to the end of this real quick analysis right here. As I told you, it's going to be fast, right? So I'm going to finish up with this. Oh, first of all, hey, do you guys have any questions? While I'm kind of saying the last few words here, type in a question if you'd like. I want to remind you guys that I'm always looking for other scenarios, so please email me if you think you have one. I will disguise your data and make sure it's okay with you as best I can. And the next thing is, the Firefighting Friday. Yes, this is being recorded. The next webinar, I'm going to post that within a few days. It's probably going to be just in a couple weeks. If you're on the list, you will automatically be notified as soon as the date is set. So you don't have to keep checking the website over and over. And if you have any questions or comments, please email me. Okay, somebody asked, let's see, where does the read by other session event come in? Okay, that was not part of this analysis, but if we had a read by other session, that is an IO related concurrency event right there. And that's, you know what, I'm going to save that. If you have an AWI report with read by other session near the top, email that to me and we will make that one of the webinars. Okay, that's my short answer to that one because that's longer than I actually want to get into right now. Okay, what if the top, another question, David said, what if the top SQL points to a procedure? Yes, well, then you need to take a look at that procedure because obviously there will be some SQL related to that. And probably if it's just not the PL SQL itself, the SQL inside of it will actually show up in the AWI report as well. But this is when you need to actually look, at the application code and to understand that. Yeah, it definitely gets more complicated. Let's see, anything else? That's the last question. Okay, guys, that brings us to the end. Okay, I will stay on here for just another couple of minutes in case you have any other questions you want to chat with. But hey, thanks for showing up. Your time is valuable, and I appreciate you taking the time to spend with me. Hope you come back. Spread the word. All right. And hey, thank you for your thanks. I see them in the chat window right now. Have a great weekend, you guys. Oh, hey, thank you, Mihai from London, from attending. All right, thank you. Fran Bisek from Slovakia. Fantastic. Hey, Tim, thanks for joining me. Also, Carl. Fantastic. I recognize these names. Jim, I'll see you next week. See you Friday. Thank you, Ken. Appreciate it a lot, man, from California. Ken, where in California are you from? Oh, I think Ken left us. All right, Jeff, see you Sunday. Ken, Bay Area. All right, I went to school in San Luis Obispo in California. All right, Saudi Arabia. I think you win the prize for being the furthest away. Thank you for being here. I know this is your afternoon right now. Nathaniel Brown. Hey, man, thanks. Thank you. Nathaniel, you had a question about how does the AWR happen to show us queries that are recursive and who the parents are. I don't think that they do. You're going to have to dig into the details outside or inside of the AWR tables themselves for that. Okay, yeah, it's an excellent question. What if the top 5 events is one? Let's see. David asked, what if the top 5 event is not one you've covered? How do you classify? Oh, excellent question, David. As you'll notice very quickly here, when I got to the 3rd or 4th wait event, the time is actually meaningless. All right. I mean, it doesn't make any difference in my analysis. So I don't care. In fact, if I was going to show like management this, I probably would not even show them the DB file scattered read. It's just going to be a distraction. In fact, this row level lock, I may not even show people that as well. Okay, because they're going to start freaking out about 60 seconds when really the issue is the 8,000 seconds. Okay, yeah, that's why you can keep the spreadsheet so small too, because you don't have to put all the wait events in there. All right. Yeah. Oh, we are okay. What's this? Abivin. How do you say Abhinav from Atlanta? We are waiting for ASH analysis. That is coming. ASH analysis is coming. Yeah. Thanks, David. Thanks for showing up here. Appreciate it. For a couple more minutes, and I'll sign off myself here. All right, guys. Well, everything's kind of slowed down on the chatting, so I'm gonna shut down the meeting right now. Thanks again for joining me. Have a great weekend, guys. Thank you, sir. I appreciate it, man. Yes, Ken, the spreadsheet is under tools. Just type firefighting, type in fire, and you ought to be able to find it. Or type in diag. You'll be able to find that. All right, guys, I'm going to stop now. Thanks. I really appreciate it. Very encouraging to me.